Hello, everyone, and welcome to Live from the Lab. This is the show where we talk about different technologies that Bruker has developed to help scientists discover the world around us. Today, we're going to continue our discussion of Dragonfly software. Now, this is a package that can be used for looking at X-ray microscope data in order to gain some additional insights into both the qualitative and the quantitative nature of what's going on in your samples. It's a great supplement to our included software package with CTAN and also CTVox and that whole package. But today we're diving deeper into this particular software, and we'll hear a lot about that. So on that note, let's head on over and start that discussion. Good morning, Billy.
Morning, sir. How are you?
I am doing wonderful.
Awesome.
Yourself?
Awesome. Thank you.
Great. And thanks everybody out there for joining us today. So today is kind of that part 2.
Yeah.
So if you're wondering about the more basics of Dragonfly, well, go ahead, watch part 1.
Right. Yeah.
Last month.
Yeah. Part 1 we did like basically how to load data, visualize, kind of mess around with the looks of things, and we did jump into some segmentation towards the end.
Yeah.
But we did kind of tease that we were going to do some deep learning segmentation stuff.
Yeah. And so here we're going to start kind of thinking about that transition from qualitative to quantitative.
Right.
Right. So these pictures, I mean, I think XRM is just so cool because like the pictures are so cool.
Yeah.
Right? The images, stuff like that. But, you know, we do have to turn it over to that quantitative side, start to get some numbers out so you can optimize your samples, optimize your processes, right?
Yeah, absolutely.
So segmentation, what role does that play in that transition of going from qualitative, looking at the data, to quantitative, actually getting out some insights?
Yeah, so the segmentation is in the analysis side of things. This is when you're trying to tease out, like let's say you want to look at the porosity. You can identify that porosity and then you would extract that volume. And then you could, because we know what the voxel size is that we scanned at, we can now assign a number value to that volume that we've extracted out. So we can assign a number value to the porosity volume that we pulled out. And so that gives you that quantitative analysis for whatever your scan is. So whether it's porosity or whether you have different phases in your sample. So if you have multiple phases, you can segment out the different phases. And so that's where we start to look at, like, if you just want to see the pores, we can do that qualitatively. If you want to know the volume of those pores, now we're getting into quantitative analysis.
So it's about connectivity, right?
Yes.
So this is something that I remember when I first started working with this technology. It took me actually a little while to wrap my head around that idea that every scan that we do, we're basically scanning that whole volume. Whether there's a sample in it, whether there's no sample in it, you're getting information. And this voxel cloud that you get then contains a data point for every one of those. And each data point contains that intensity value or the absorption value, right? Our brains, we go, oh, similar colors, that's all connected.
Right.
But the computer, don't know that so much, right?
Yeah, so the computer just sees it as, like you said, it's just all one big scan volume.
Yeah.
And so the computer knows, like you just said, you can see, and we have a really good example here, but the computer, we can see it really easily. But you have to tell the computer what's what. And so depending on what and we'll get into the attenuation values, but depending on how well your sample attenuated or absorbed the X-rays, then it's going to be easier or more difficult for you to be able to threshold these things out. Even if it looks super simple to you, it's going to be it's not always as easy for the computer to decide that.
Right.
Or determine that.
And then once you've figured out that connectivity now and saying, you know, that, like say that you had the classic, just a pore in the middle of a huge material, and you say, oh yeah, obviously those are connected because there's no absorption in that pore. So all of these pixels are connected to each other and we see it. Well, now that we've actually connected them, then we can start getting those statistics of the size of the pore and the shape of the pore and things like that.
Yeah.
Right? All right, so this is really exciting, really big topics. We're gonna jump into it. One thing though, if you do have any questions as we're going through it, just go ahead and type them on the side of the screen there. We do have some questions that had come in before the broadcast. You can actually always send them in. We have an email, live.events@bruker.com. If you see a topic you're interested in, type it in there and we'll make sure to address it. Or if you're watching this episode later, go ahead, send us a question there, and one of us will get back to you with an answer. So with that, let's take a look here at the computer.
Yeah, so we have our concrete sample that we did last time. This is what we did towards the second half of, or in the second half of last time's episode. So I kind of have it colored a little differently here, and if you remember, under our main segment, or our main tab, we have this lookup table, or LUT, that we've loaded. It's the rocks too. So it's colored differently. This is nothing is quantified or identified yet. This is just the lookup table.
A grayscale, it just takes the histogram and applies a color to that.
Right, yeah.
Okay.
And you could change these colors if you want. You can double click on one of these nodes and then you can change the colors. But
now in the histogram, so this is that graph we're seeing on the left. That's almost always viewed in log scale.
Yes.
And then we see these kind of peaks. What are we talking about here? This is like, what are the axes on this? What are we like? What's a peak mean in that histogram, or what does even the histogram mean for people out there?
So this is an 8-bit data set. So you can see down here it goes from 0 to 255. That's 8-bit. If this was a 16-bit data set, it would go to 65,530 or something like that.
Okay. So that would be the range of shades of gray.
This is it's like the number of buckets that we have in here, and so the grayscale values fall into each one of these buckets. So for this, what we're looking at on the far left side, this is going to be our void space. So if I drag that over to the left, you can see the void space is now visible. And then towards the right end is going to be your higher density. So anything lower density is going to be to the left, and anything higher density is going to be to the right.
Okay, and so then this is like, basically it's like a bar chart. And it's just showing the number of voxels. So we call them voxels because they're 3D pixels.
Right.
In each of those color buckets, or in each of those intensity buckets.
Right.
Okay.
Yeah. And so you can see these little mounds or kind of isolated peaks here. So each one of these is where more data. So there's more data here, or this is like kind of. So if I drag my histogram around here, is it going to show me very well? It's kind of hard to see here.
We've got that LUT that's being applied right now.
But that's.
We'll kind of see that when we talk about segmenting.
Yeah, right? And you can see it with the coloring. So the gray is, we have this peak as gray, and so that's more of our matrix material, like the Portlandite and the concrete. And then these larger clasts are these lighter browns. So that's going to be this peak. And then as we move out here, we have the higher density, which is, it's hard to see, but it's these wider chunks that are in the middle here.
And now just, I guess, a little bit of thing on the program is I see that the color here is being applied to your 3D view, but it's not being applied to the 2D views.
Right. If you click, so you see the red line around this 3D box. So if I click in 2D now, I'm over here, and you can see my LUT changed. So I'm actually in, my lookup table is now grayscale.
Yeah.
But you could change it to something else if you wanted. So.
And you can have different ones for the 2D versus the 3D view.
Right.
Okay, so now with that, let's say that we want to start this journey of turning our awesome looking data that we see things in to help the computer to identify it with segmenting.
So now
what do we do? What's our first step?
Yeah, so now we're going to go into segmenting. So we did a little bit of this last time.
So you had a tab there, huh?
Yeah,
go over to the segment tab.
On the top left, we have our main tab, which is kind of how we manipulate everything on the screen, lighting and color and stuff like that.
That's our view, our qualitative more.
Right.
Okay, now segment, so now we're going to quantitative.
So now we're in our segment tab. So there's these 3 windows that you can open. I'll be in ROI tools.
What's ROI?
Region of interest. Okay. So we're going to, so basically we can create a region of interest. And there's a bunch of different ways that we can do this. And we talked about some of this in the last episode. So I'm going to skip over some of it. But let's say, let me go full screen on here. So one of the things I like to do is I like to do define range. And then sometimes the histogram isn't there, so you have to actually open it up. Okay. So now we have anything in red is what's going to be selected or identified. So thresholding is binary. You're choosing something that's either on or it's off, like a flashlight. So right now, we have all the void space. I mean, anything on the lower end is selected. It's identified. That's what's in red.
So to be very clear, because sometimes red means excluded, here this reddish color is meaning chosen.
Right.
That's what we're picking.
Yeah.
Okay.
So like, let's say if I wanted to keep this, like I wanted to, this is my void space. You can click add to new. And so now you have this new ROI. And so this is what we have selected as our void space.
And then what we can do even, right, is we could turn off the concrete volume and we'll only see.
Yep.
So now this is the void, but this is the outside bits and it's also the inside bits because it's just based on the absorption.
Right.
And the little pores on the inside, the outside air, that all absorbs the same. So it's very simplistic segmenting.
Well, and like you mentioned, this is the entire scan volume. It's going to work on the entire scan volume. So we know we're only interested on what's inside the concrete. The system, the computer doesn't know that. So it's
that seems to work pretty well, though.
Yeah.
For doing this. Does that also work for some of those inner features, especially where that histogram had a little more convolution?
Yeah. So and now we're going to get back to these peaks that we saw. So this peak is probably more of our void space, or it is our void space. So as we move and now we highlight, let's say we just straddle around this peak. So now we can see we're looking at more of the matrix material, right? So we can do that as a separate. We can do the larger class. So now we're getting into some of the difficulties of segmentation, because as you can see, if I just want to get these larger class, I need to go maybe a little more this way, and then a little more this way. I'm still missing some in here, and I'm also picking up some of the Portlandite or some of the matrix material. So I don't want this. So this is where you start to get into, like, you need to do this, and you need to do some fills, or like in CTN it would be despeckling. So this is
the speckling.
Yeah.
That could be there, but it could also be noise, right?
Right. Yeah. And so yeah, this is this is one of the problems when you have. So this is a much easier example. But like, for example, let's look at some of these darker spots, right? So what if we just want to identify that? It's in the matrix, we know, and so it's not void space, and it's in the matrix. So if we just want to tease that out, you can see this is a perfect example of where segmentation can become really difficult.
Right.
So it's matrix, but it's like a lower density phase in the matrix. So these lower density features are going to be very, very difficult to segment out from the matrix.
And that's where our brains,
right?
I'm going to drop the word natural intelligence, right? So our natural intelligence looks at that and goes, I understand that the darkish color,
right,
and the darkish color more distributed in the matrix, those are similar colors, but obviously the stuff there is one phase that's different.
Right. And so depending on what your material is, like let's say, so in concrete, what this could be, I don't know, I'm not a concrete expert, but what this could be, I mean, this could be something that just didn't mix very well together. So it could be something like that, or it could be something where the moisture got pulled away from this, and so we have this like spot of low density or something. But whatever your material is, maybe this is the feature that you're trying to avoid whenever you're making your product or whatever it is.
So looking at this, it looks like this segment by histogram for this sample would work well if we were doing the pores in the outside, the air,
right,
and then we were doing the large clasts,
right,
and then we were doing those big old white chunks.
Yeah. So if you're doing, so we can see there's really good grayscale differential between the matrix material, the voids, the class, and these higher density features.
So if that's the level you need to be at,
right?
Yeah, the tools, that's going to work. Or if your sample in the histogram, we happen to see very good separation between things.
Right.
And for everybody out there, keep in mind, we're looking at that on a log scale. So if you turn off the log scale, you can see like they're decently separated.
Yep. But
that being said, little speckles, they make up a lot of voxels.
Yeah. And like I said, so let's say we add this to new. So now we have this ROI. So if we did want to do that, you can right click on this, refine region of interest, process islands, and then from there you can do, and this is despeckling in CTN. This is similar to despeckling in CTN. So you can say remove by largest, or you can say remove by voxel count or something like that if you want. Mm-hmm. And then that can help clean this up. So you can go there and you can remove. Yeah, you can remove some of the stuff that you don't want, and then you can fill in other parts that you don't want. You have all your, over on the left-hand side here, dilate, erode, open, close, and smooth. So, and then fill inner areas in 3D, which we did in the last episode. Yeah. So you have some of these features that you're very familiar with to begin with. Yeah.
But you are kind of like fixing it up.
Right.
And what's neat about this software is that they've kind of also given us some more advanced ways of identifying some regions, right?
So yeah, and there's some of these that I really like. So we have this ROI painter. Oops,
okay, so just to be clear, what we just did now is we switched from the tools, ROI tools, and now we're on ROI painter.
Yes, but I did mess up. So under ROI tools, I need to add, so let's say large class. Oh, why is it not typing? Oh, keyboard needs to be on, of course. Okay. Large class.
That's the old IT thing, right?
Yeah.
Turn it off and on, but you turned it off. You forgot the on.
So that's ROI tool. So now we have created an ROI. Okay. So now there's nothing in here.
Yep.
So now we can go to ROI Painter. And then in this brush mode, if I click that brush, we're looking at a single slice. If I hold down Control and scroll, I can increase or decrease the size. So now I hold down Control, and now I can paint. As you can see, yeah. So you can paint whatever you want.
Okay.
If I hold down Shift, I can erase. So this is kind of a nice feature to have. Now I'm going to erase this really quick because I want to show you something else. We have this down here. These are just options to help segment. So I'm showing you different tools that Dragonfly has.
You got to find the right one that works for your samples. Oh, that's kind of cool. So like it almost makes like a little map. Huh?
So now all of a sudden, I did this grid. So and you can adjust the grid size. So if you want to kind of get a little more strict, we can do like this. And so now we have a way more strict grid. It's going to basically, it looks at the grayscale and it tries to identify, or it looks at the it looks at the grayscale of the image that we're looking at right here, and it tries to identify, delineate, like it's making lines on what it thinks are features. So, and actually, one thing we are seeing it is, and I'm doing Control-click again. It actually is identifying these low density features pretty well.
So in there, you've got two things you can play with. You got grid size, and that's going to change whether you're looking at very fine features or more macro features.
Right.
And then you got sigma, and that changes your sensitivity to the differentials. If you set it too far one way, it's going to be too sensitive to noise. Set it the other way, it's not going to catch up on subtle adjustments. So you got to kind of play with these things a little bit, right?
And so again,
it's really amazing what you're doing. Okay, now when you click, though, what it does is it fills the whole region that you've touched, right? So you do have to be a little bit careful. You don't have too big of a cursor here.
Right, and so you need to make sure. So like, let's see. I think this one looks like. No, so some of these, like, it's if you're trying to avoid, there you go, if you're trying to avoid the void, this one, it didn't delineate the void very well right there. So there is, if as long as it was only one click ago, you can click the undo button and it'll undo that one.
There's no Control-Z, Control-Z,
Right, but also like you said, if you need to make sure that your cursor is the appropriate size. So if I'm doing this, if I know this whole grain is, I can click that whole grain. But if you do that down here, it's going to select way too many things.
This is a tool I actually really like using too for like doing fix-ups or touch-ups.
It's really nice in the deep learning segmentation tool, which we're going to get to. Something else that I wanted to show is the segment anything model. So
now this is our first little dip into the instead of natural intelligence, the artificial intelligence.
So now what we're looking at is I have this model selected. So if I want to, I can just do Control-click, and basically it's going to look, there you go, look at that, it's not bad. So it's going to see what I clicked on, and it's going to fill in whatever it thinks is one grain for that feature. So depends on, sometimes it works really well. Did I click in the right spot? Yeah. And then sometimes it's gonna have trouble. So like if I want to identify that, let's see what it does.
Now, and to be clear, so if you were doing this, though, if you're really doing this, you would want to have multiple phases up there, right? You can add additional phases, and then you can use this tool to add. How do you do that? So, like, what if I use a segment anything, but I want to make 3 or 4 different phases?
So you can go in, you can add a new one. So let's add.
Okay, so that's kind of under that ROI tools set, and you just got to add some more phases to it.
So we'll just add another phase. So we'll say this is voids, and then so now that we've added a different phase, let me show you a different way to do this. So define range log. Now let's just look at our voids. So and one thing we saw earlier is when we did this, it added everything on the outside, right?
Yes.
Well, I don't want to add everything on the outside. So I would much rather, so let's have our void selected. We'll do our brush mode. And if I hold down Control and I click here, nothing's happening, right?
Right.
But as soon as I go over the define range, so now I can paint, and it's only picking up what is selected or identified in define range.
Only the selected, and that happens to be the red color right now.
And then if you go outside, whoops. All right, so now we can.
And it does, like right there, what we saw is it doesn't take the whole region, but because you're using the painting tool, it only paints the region that you touched.
Right. So this is kind of a nice little. I love using this. Yeah. That's a nice little feature to have. So now you can.
Could you combine that also with the grid tool? Like, because I noticed that some of the edges there, they don't look so perfect.
Yeah, so now we can apply the grid and then control. Uh-oh.
Whoa!
So that's my mistake. I thought that would have. Oh, hang on. Oh, no. Sorry. That's my mistake.
Okay.
Yeah, so you have the grid on.
So then you could go back. So you could go back now, and you could touch up those little bit. You got to make sure that the cursor is tiny.
Right. Yeah.
All right. So now this was ratcheting it up. So we started with the histogram, segmenting. Then we went up to the painting, and we just did painting by ourselves. Then we did painting with a grid. Yeah. And now you just showed us how you could swap. Like, you could use the histogram tool as a guide, but then change the colors back and forth.
Right.
And then we did segment anything.
Right.
And that's pretty cool because basically you could take any sample in there, and if you can visually see it, generally it's pretty good.
Right.
Right? And all these tools are going to help us lay the basis for that next step, which is really doing an AI thing.
Yeah.
Where we train it.
Yes. So now we're going to get into their deep learning or AI segmentation. So if I already have it done, so I'm just going to open this, but just to show you, you can right-click on the volume, segmentation wizard, and then basically that's going to open. It's going to. Now I'm opening the segmentation wizard. All right. So this is.
And if you were to open it to begin with, you just wouldn't see those frames you already have in there, and you wouldn't have the model loaded.
Right.
It would prompt you for a model.
So it would prompt you to create a model. Yep. So and then basically what we're looking at here, oops, let me do this. So let's say we wanted to.
Yeah, if you're starting new,
right?
What does this mean? Model. What is the model? What does that mean?
So the model is basically, it's going to have all your training data in it, and so this model is what you're going to give it all of its ground truth. Now the model has all the parameters, so you can define what type of model you're using, the depth level that it looks at within your data set. And then there's a lot of little parameters and features that you can adjust. You can make it really complicated. You can make it really simple. But this model, what you can do is you can take this model and let's say we build it for concrete. So now any concrete sample that we have, as long as it's relatively similar, you can use the same model for it. So
it's like you have a new colleague, right, at work, and it's their first day.
Right.
And the model is just kind of that new colleague. So they might have some basic idea. These different models, they have a basic understanding of like, it's a picture. But they don't know anything about this material. They don't know anything about that. So we're going to have to train it. We're going to have to tell it.
Right.
This is a class.
You have to tell them what's what.
This is the matrix. This is that. And we have to be very careful that we're telling them the truth.
Exactly, yeah.
Not being ambiguous, because otherwise they're going to give us ambiguous results.
Exactly.
Now, choosing these models, there's a whole bunch of them here. And how do I make the right choice?
Yeah.
Or what's the default choice?
And of course, if you're new to this, you're looking through UNet 3D. So the one that we have typically started with is pre-trained by the Dragonfly team. So this one, it has seen a lot of different types of materials and a lot of different data sets. So it's
specifically micro CT data.
Correct. Yeah. So it's seen a lot of different variety of materials. So it's a good baseline to build whatever you're going to train it on, because at least this pre-trained model has seen something. So it has some previous experience, right?
Yes.
It's not coming to us as a fresh out of school.
So if this was a type of sample, instead of just getting a new colleague, now we know it's a new colleague who's a geologist,
right?
Or it's a new colleague who has looked at micro CT data before.
Right. Yeah.
Okay.
So then so you can change like the depth level that it looks at. So how many slices you want it to look at. And then once you create your model, now you can go in and you can change the patch size, which is whenever the model whenever it zooms in, it's going to look at a patch X by X number of pixels, right?
Yeah, it kind of like, the way it digests these pictures is it cuts it into these little pictures,
right?
And then it says, yeah.
Like a quilt. So it's going to cut it into all these different
That's a great
patches.
I love that.
Yeah.
That analogy.
Right.
It's like a quilt. Yeah.
So it depends. You can have it look at larger or smaller patch sizes, and what I like to say is depends on what feature size you're trying to identify. So you're going to change that patch size depending on what you're trying to identify. So, and there's a ton of, under advanced settings, there's a ton of different parameters in here. This is, I mean, you could do a full day on this.
And the augmentation, we can talk about that when we get to the training part.
Yeah, so augmentation is another thing. So anyway, so you would come in here and you would adjust your model parameters. So the first thing you need to do, let's go to a slice that nothing is done on. So if you click on slice and drag, you can slide around. So it's a nice little quick feature to have. So one thing what I'm doing here is I want to find a spot that has all the phases that I'm interested in. Okay, so like this is a good spot. So, and what we need to do is we need to create a frame and we need to give it some ground truth. So what does that mean? Let's create a frame first. So now we have this frame, and then it has all of the phases that I want to identify in this frame, okay? So now we have this one frame. We need to, I know what is void and what is classed and what is this high density classed, and then the matrix material. I know I can see this. And you can see all of our phases. Again, we've already done this. So voids, matrix, large class, high density. So we can see where all this is.
So
right?
if you're starting with an empty one,
yeah,
you would have to go in and you would have to add the classes, and the classes, like you said, are the buckets you want them to throw stuff into.
Yeah, so if you need to add a class, you do it over here.
Okay.
Yeah.
Now, ground truth. So I think one thing that's very important with this, and really you need to reinforce in your brain, is that you need to tell it the right thing.
Right.
Here, you need to be clear. There's no room for ambiguity when you are doing these trainings.
Yes.
Because otherwise, it will just do as you instructed, and it will also give you ambiguous results.
Right, yeah. If you don't know what it is, how's a computer going to know it? You have to tell it exactly what is what.
Yep, this is how I want you to sort it.
Right, exactly. So if you don't know, the computer won't know. The model is only as good as it's been trained.
Yes.
So as the information it's been given.
Yep. So
like you just said, ambiguity. So if you give it some ambiguous data, then it's going to return ambiguous data for you. So so this is where So
start simple. Start with frames that look easy. And I think the other thing to take note of is how you were able to reduce the area of that picture. So you don't have to label as ground truth the whole picture. You can start with just pick a corner that you really know.
Right.
And start there.
So let's just do the voids for now. And so we can just very simply, let's just do this and this. So we can say, you know what, and I'm going to use one of my tools. So we can just do this, and we can say add. And now it's going to add that to the voids, because I'm selected on voids. Oops. I'm selected on voids over here. So now it added all that to the voids. And then let's say we want to do the high density. That's going to be way more over here. Maybe this is how you want to do it. Maybe you want to use the segment anything model. So we have the segment anything model. So we're selected on high density, control click. Okay, now we have that. Maybe we want to do the grid for the classed. So now I can do this. Oops. 32, let's change. I always like to change this 64 by 64. So now we can do this, and we can select the large class. So I'm holding down control and dragging. I can use the larger here, right?
I would say this is one of those things that does take a lot of time.
Yeah,
you really need to be thoughtful about this, and you have to be very, very attention to the edges, like where you have the interfaces. Right,
yeah, the edges, that's a good point. The edges are the most crucial, because that's how the model is going to learn where to delineate the different features.
So what we're doing here, we're doing it very fast.
Oops.
And you would want to go in here and really get those edges right. And even those little tiny bright spots, you'd probably want to label those as another phase.
Right.
Yep.
Yeah.
So you would want to be very careful. I think you do have some examples that you had already done before. So we can look at those. But we would label all of these, and now we'd have the ground truth frame, right?
Right. So you can change the opacity. So now we have this. So this is a ground truth frame, right?
Yep.
And then we also have what is called a monitoring frame.
Okay.
So what this monitoring frame is going to do is whenever we train the model, it's going to, as the model trains and learns from the ground truth that we've given it, it's going to display what the model and we'll demonstrate this, but it'll display what the model thinks each phase is, or how the phases are going to lie on this one monitoring frame. So you can kind of track how the progress of how the model's doing.
Another cool tool, I think it's kind of cool here, is that once you have trained it a little bit,
yeah,
you can actually use it to start predicting it, and then you can use that to kind of help you with labeling another frame.
Let's do that.
Right?
So here's this frame that I was just messing with, right?
Yep.
So let's just say predict. So it's going to predict based on the other data that we've given it. So if you double click, so this is what it predicted. Now again, we've already given it some training, so so I selected down here.
You can start with real simple, do a few simple frames that you can really nail well.
Yeah.
And then you can kind of grow it. Or even you can take a frame, like here, you took just that part of it, and then now we could expand it. Once we've trained it again on this data, we can expand it more, and then we can use that to predict, and then that helps to cascade making this whole process faster.
And you can see like here, so I would say it didn't do this correctly.
Yeah, so we got to fix something. Huh?
So one thing I love this. So we can choose brush mode, so we can see.
Billy's favorite features.
This is labeled as large class.
Yes.
I think it should be labeled as matrix.
Okay.
So it is labeled as large class. Control click matrix. So now we have A and B. So now it'll change if I hold control, it's the large class color. If I hold shift, now it's the matrix color.
Okay, so the ring is changing color.
The ring is changing color, yeah. So if I hover over any of the matrix and I control click, it's going to change that. Now if I do that on the void space, it's not going to change the void space because I only have these two selected.
So it only will take the one color and swap it to the other color, but it'll leave all other colors as they are.
So what I'm going to do here is I'm just going to go, I think this spot needs to be matrix. So I'll shift, let's fix my example there, and then I can go like this.
There you go.
And now it's fixed, but it didn't affect my void. And then same, so over here, I want this to actually be, if I scroll down, you can kind of see that actually looks like it's probably one of the like a chunk of the larger class.
That little thing you just did, by the way, that's also a really good tip for people.
Oh, yeah.
Right? Is like, if you don't know, you can kind of go to a frame down or a frame up and get an idea of what's going on here.
Yep.
And you're doing that how?
So I'm just scrolling. I just scroll down. So if you look on the top left here, it says slice 218, so 17, 18, 17, 18.
Yeah.
So I'm just going to use the grid feature and do that. And so now I feel like that's a little better representation of that class.
And again, we're being very quick here for the demo purposes, so we would want to go in and really get these things nailed. This is like probably one of the most important things.
Yeah.
Is to really get this truth, the ground truth, right.
And one of the things, I know we talked about this in the intro, or in the beginning of the talk here, but this lower density, this is part of the matrix. So for simplicity purposes, I'm just considering this part of the matrix. You could make that another class as well, or another class as well. But I wanted to point that out. I know we did talk about that phase. Yeah. I'm just considering it part of the matrix.
All right. So now let's say that we've gone through, we've made several ground truth frames.
Right.
And then we also picked another frame, and we didn't do the ground truth, but we just said, I want to use this as a monitoring frame, and you'll see where that comes in a second.
So you just double click on that and you change it to monitoring. So these are mixed, which are the ground truth, and then this one's a monitoring frame.
All right. So now what's our next step?
Let's train it.
Train. Okay. If predict, by the way, is grayed out, it's because you never trained it. You need to train it at least once before you can use that predict feature.
Right. It doesn't have anything to predict on. It doesn't know what it's predicting. So this is the training window that we see here. Now at the top, basically, it shows you all the little details and settings for your model. So the architecture is a UNet model, depth level is 6. It shows you your patch size over here. And then the augmentation. So data augmentation is a factor of 10. So
now that was that tab.
Yeah.
And you could access that. So if you went over to your models tab.
Right.
And you go to the last tab there, it said augmentation. What does this mean?
Yeah, so what it's going to do, so augmentation factor of 10. So what it's going to do is it's going to take all these slices, and it's going to look at them 10 different times. Or sorry, it's going to manipulate them 10 different times. So it's going to flip them horizontally, it's going to flip them vertically, it's going to rotate 180 degrees, zoom, it'll do some shear. And so what it does, it's distorting the image and seeing how the ground truth compares to the data set. And it can help the model learn where the delineation is between the classes.
Yeah. So I mean, the AI model here, it's just like a real person that it gets smarter the more things you present it.
Right.
And humans, we're very visual. I mean, even as babies, we learn these things and we go how to look at the world around us. And so when we see things like, oh yeah, that's just flipped a mirror image, right? Yeah, that's obvious.
Right.
Or it's rotated 100. Oh, that's obvious. But it's not obvious to the computer, and that's what augmentation is doing. Taking that data, rotating it, skewing it a little. And so the more you augment it, the smarter it's going to get. But be thoughtful, too, that you're just skewing the one frames or the frames you've selected.
Right.
So if given the choice, you also want to expose it to a lot more frames.
Yeah, exactly. So, and this is a much easier data set to segment. I mean, you could do this without using AI segmentation. So in more complex data sets, like if you're trying to do that lower density phase in the matrix, that's where this is going to be way more useful, and it's going to take way more frames, seeing the difference between the matrix or seeing the differences in the matrix.
So now we see the monitor frame popped up. So that was the frame that you chose monitor, and then it's just showing how it looks.
Yeah. So yeah, exactly like you just said, this is the frame that we had selected to monitor. So
So if the first time you're doing this, that monitor frame doesn't look so hot,
don't freak out.
Just let it go. Let it go. It's going to think about it, and it's going to fix it up the next time, right?
Yeah. So you can change how the opacity of the classes or the segmentation, and so you can kind of see it. Is it doing a good job? Is it do I like what it's doing? It's fine if you don't like what it's doing, like you just said. It's going to go. So basically what we're looking at is see this validation loss down here at the bottom. Yes. So we want that to get as small as possible. And so as it completes its next training, we'll see this graph change. And we want that val loss to keep dropping. So what it'll do is it says training will stop in 15 epochs, that's what it's running one right now. So it'll stop in 15 unless the val loss decreases. So it'll go for however many epochs we've determined, 100, unless it has 15 in a row where it doesn't see a decrease, which is an improvement.
Right, right. So and what it's doing there in the background is it's predicting those ground truth frames. Then it's comparing it to so it's comparing the prediction to the ground truth we fed it.
Right, right.
It's saying how close are you, from that prediction. And then based on that, so these AI algorithms, they have basically like scoring systems inside where they incentivize. So it's like all these, the kids these days, they got these apps with the badges, right? So it's like inside the AI is getting the badges or it's getting the little gold star. When I was little, it was a gold star, right? You got the gold star in class. So we're giving the AI gold stars, and it needs to get more and more gold stars each time in order to be better. And that's what those numbers are you were just talking about. Let's talk a little bit about speed, though, because this is something, we've all heard it on the news, that AI training takes a lot of power.
Yes.
So we got a pretty beefy workstation.
Yeah.
And even then, you can see that bar is only moving so fast.
Yeah, that's true. So, a faster, so this computer is our standard workstation that comes with our instruments right now. The graphics card has 20 gigs of VRAM. So, and I think you'll see it's working. It's going, yeah. So you can see the GPU is working pretty hard. So the GPU is what this learning segmentation works off of.
And that's why we hear, like in the news, like, oh, AI, and then like NVIDIA. Because NVIDIA, they make these GPUs, and they. So what we're seeing here, though, is it hits it heavy. We got that GPU really being used. The CPU is being used too. Yeah. So this takes a lot of power.
Yeah.
So don't try doing this on the old laptop.
Yeah.
Well, you can do it. You could do it, but
could.
it'll just take longer.
Yeah, I mean, if you're going to do that, you probably need to downsize your data set or use a subset of your data. But yeah, so it is definitely very computer intensive, or it can be anyway. So
now, Billy, do I have to redo this whole training thing every single time now I want to use this model?
No. So like once this model is trained, so we got 20 seconds until this frame is done. So once this model is trained, now this can take a while, like getting the training done, adding all the frames that you need, and letting it learn enough. So kind of like training a new employee.
Yeah,
like
it is. This really
time.
is, right? It's bringing so. But the time you invest in it,
there we go. Now we got a balance.
You're going to get wins, right? Because in the future now you can just apply this, and you can share these models too, right?
Yep.
So once you have that model all trained up, if you got a colleague at another location in your company, you could send them that model, and they can use it.
Yeah. So I clicked stop on our model here, and I clicked stop, and basically, so the monitoring frame, this is what it ended with. Yep. You just double click, and it'll go back.
Now,
so,
and that looks pretty good. Now, if this was going to be like I'm in the concrete thing and this is really my model, maybe I'd want to go in there and fix up some of these things, right?
Yeah.
Do a little bit closer with the small areas.
You might need to add, so depending on how well the model is predicting your data, or identifying your phases, you might need to add new frames. You might need to introduce it to some more complex frames. Sometimes one of the things that we've seen is you need to go towards the ends of the data set where there can be some edge effects.
Yes.
So that can be really useful, especially like if your sample starts to, if it gets thinner or something at the end where you have way more air and way less sample. Sometimes it can get confused and try to identify.
Yeah, in fact, in AI training, another one of those terms you might hear in the news is this edge case.
Yeah.
Which is, you got the bulk of things fit in the middle, but this is weird here and this is weird there.
Right.
And to be frank, like, even if we were experts in this, sometimes we encounter those things and we go, well, is that this or is that that? I don't know.
Yeah.
But it is relying on you making that call.
Right.
So, okay. So we got this thing trained.
Yep.
We're all happy with it. I guess one other bit about training, do you ever go in and retrain? Like, say we're using this model, like we're doing the concrete thing, we're happy with it. Would there ever be a case that I should go back and say, like, run a scan on a sample and then go back and check it up a little bit, give it some new frames?
Yeah. So I mean, let's say that you're primarily working on, like, we have concrete. So let's say we're primarily working on concrete, and then somebody comes along and they say, well, we want to use this new version of concrete, and the matrix material is different. Or they started using a different aggregate in there, or whatever it is. So they've done something. So now your material has changed. Is your model going to be able to identify those? Is it going to be able to see those different materials now in the same way? It might. You can give it a shot first. So if your material changes or your sample type changes, you can give it a shot at first, but best case, it's way better to retrain or to add that data set to the model and train it on that.
Yeah, and you kind of have to make that call. If it's kind of just your material is changing, it's migrating. Maybe you're digging a hole. Maybe you're getting different source material, whatever. It's still fundamentally it's the same materials, just a little different now. Morphology is a little different. Density is a little different. Then you add that case. It's just another edge case. You're just migrating that model.
Right.
By the way, I would always probably suggest saving a copy of the old model.
Yeah.
And then make the new one.
That's a good point.
But if you're talking something new, like you're really swapping out that matrix, you're really swapping out the aggregates, you probably want to make a new one.
Yeah.
Okay, so what do we do now? All trained up. We're all happy.
So
I now have another sample, or I want to do something with it.
Well,
what do
now
I do with it? I want quantitative stuff.
We want to use it now.
Yeah, I want to use this thing.
So you can export it. If you click exit, it's going to ask if you want to publish it. I don't need to publish this.
Because you already published it.
Yeah, I already have it published.
You do have to publish it.
You will need to publish this.
And publish doesn't mean throwing out into the world. Publish just means it's going to save it internally here.
So we're back in our segment tab. Segment with AI is down at the bottom here. So one thing, I created this mask. So because one of the options that you have here so I have the concrete volume selected. We're going to use our concrete model. And then down here on segment, you can say with ROI as mask. So the reason why I like this, because if I just do the full data set, it's all that void volume along the outside. It's going to be present. So if I do it with the ROI as a mask, then that void volume on the outside is going to be gone. So let me just click it. Object concrete mask. Yeah. So
and
that's
to create
ROI.
the mask, you just can go in and use those tools that we looked at, the ROI tools,
Yeah.
or the painter.
We actually talked about that on the last episode. Basically, what you would do is you can do define range, identify material, and then you can right click on that ROI that you created, fill inner voids, and then it'll fill everything in.
And then what you did is over there, then you also you just chose the model you wanted to use, which was the concrete one. And then we just hit, what button did you hit there? Segment?
So I did segment with ROI as mask, and I chose the concrete mask.
Okay.
Yeah, as my ROI.
All right, let's see what it does.
Boom,
hey,
there you go.
That looks pretty good. Huh?
Yeah, I like it.
So now, let's say I want to know, like, how much, what's the porosity or something. Can I do that? Putting Billy on the spot here.
Yeah, sure. Okay, so all right. So what I would do for that.
Yeah.
So here's all of our voids.
Okay.
So I will say.
And that's got a number. It says count. What does that count?
So the count, that's the number of voxels.
Okay.
So that the number of voxels that have been labeled. Okay. So this is not a volume or anything like that. There's nothing quantitative assigned to this as of right now. So what I would do is I would right click on it. And where is it? Extract classes and ROI. Okay, so now I have this. I'm just going to say voids. Oops. All right, let's just back out the whole thing. Voids. All right. So now I have voids, concrete mass. Now this concrete mass is basically our entire.
Okay, that represents the whole volume.
Right.
So we got the volume of the voids and then the volume of the concrete mass.
So compare with voids. Did I do this correctly? Yes. Okay. So
1.5% volume.
Yep.
Well, I hope that matches the number we found in the last episode.
Well, again, the last episode, we also did this very quickly as well.
Yeah.
So, actually, I think it's
You're
close.
giving yourself a little bit of breathing room there, huh?
Yeah,
Like,
of course.
I know.
Absolutely.
Yeah.
So, I will say one thing, this is just me, like, I was looking into. I can see there's some stuff that needs to be cleaned up, but again, we only had 3 frames that it trained on, so, I'm not. This is pretty good.
That's how you would now get a quantitative result. Or you could go in here and you could do any of those other mathematical things on those things. So you could look at the shapes or the sizes of the class phase. You could look at all of that information now because it's separated and segmented.
Right. Yeah, exactly.
And you can make those really cool pictures like the one that we had for this episode.
Yeah.
Right?
So here's our voids extracted. And then let's extract the large class. We can do that in 3D. So also for these, we can change diffuse, specularity, highlight, just some of the things I like to do.
All right. So I think that was all the stuff we wanted to do, right?
Yeah. Yeah, so now we're kind of getting to the spot where we have some really cool images.
So
and the only thing I will say, we did talk about in the last episode, we did talk about going into this and creating your multi-ROI and doing the compute measurements so you can get your volumes, you can get your quantitative analysis.
So we do have a few questions that came in beforehand. Again, if you want to send them in, you're watching this thing later, send them into live.events@bruker.com. Otherwise, right now, you can just type them in on the side of your screen. We'll get to those. First question, though, that had come in before from Juan, what is the histogram showing?
Yeah, so the histogram, scroll back down over here. So the histogram, I'm in 2D. Let me uncheck these things. So the histogram is actually showing, on the left side is going to be the voids, on the right side is going to be your higher density. So basically the histogram, each one of these bars that you can see, these are buckets. And so depending on the amount of attenuation or X-ray absorption that material has, it'll fall into this range of these buckets.
And we tend to say like it's kind of density. Towards the right is higher density, towards the left is lower density. That's actually a misnomer though, right? This is not technically density. This is...
It's related to density, yeah.
X-ray attenuation.
Yeah, so it's attenuation. So it can be, I mean, yes, this material is attenuating differently than this material.
Yeah.
So and that's what we're seeing in the histogram. It is related to density, but this is not a density. This is not based on a density measurement.
Yeah. Yeah. All right, Stephanie, I work in pharmaceutical development. What type of segmenting would you recommend? So we talked about many different types. We had the histogram segmenting, then we had the painting tools, and then we had the AI. If you're in pharmaceutical, is there like a silver bullet here?
No, I mean there's not. I mean, I guess the nice thing is you have options.
That's true.
You have a ton of options. So I would say if you're looking at doing voids versus material, then just your basic segmentation is going to be fine.
Mm-hmm.
If you're looking at teasing out, like let's say you have two different phases within pharmaceuticals. Let's say it's like a pharmaceutical tablet.
Sure.
Okay. You have different phases that are very similar in attenuation. Then maybe you're gonna you can see the difference, but the segmentation tool can't really see the difference. Then you might need to go to use the deep learning segmentation. So there's a lot of times when people are like, whoa, I just want to use this deep learning segmentation. It's overkill. It can be overkill. Sometimes basic segmentation can be easy enough.
So right tool for the job, and when we say job, we mean even sample types, not your old job.
Yeah, exactly.
All right, Malachi, how long does it take to create a good model? Well, we saw a little bit of it here.
Yeah. So this example is really nice because it depends on. So if we're just doing the matrix versus the voids versus the large class, it was really easy to delineate those.
Yeah.
If
we want to get those matrix phases, those really dim things.
Yeah. So if you want, so it depends on how complex your data set is. The more complex the data set,
it depends. You apps people, you're always saying, it depends.
Yeah, exactly.
What are we talking here? Come on, like hours, a day, a week? What would you generally set aside if somebody said, I want to do AI?
So I mean, we did this one in like an hour.
Okay.
But a more complex data set or let's say you have multiple, you want to build it to where you can put a bunch of different sample types that are all like very similar in nature.
Yeah.
That can take, it can take months. You have to put all the data in there. You have to define all the different frames. If you have multiple data sets, each one has to be analyzed. Like it depends on how complex you want to make it. You can make them really complex.
You kind of have to circle back and try it out.
Right.
See how it's working for you, and then maybe add in a few more cases and stuff. Yeah. And as always, you got to have good data to start with. If you got bad data, no point in even starting.
Yeah. I mean, we said it on the last episode. We'll say it again. This is the garbage in, garbage out. So bad data creates bad data, bad scans, gets bad reconstructions, and then bad analysis, right? So it's just, and it grows, it's exponential.
But segmentation is the foundation for the rest of your quantification. So getting this right is absolutely essential.
Exactly.
Nice thing is, if you got a process you're doing here, like you were looking at this type of concrete all day long, man, you invest that time in it, you invest the computing power, you got something that you can really depend on long term.
Yep, exactly.
All right, last question that came in was from Priyona. Can I create one model for all of my samples?
As long as your samples are very similar in nature. So like if you're dealing with all concrete samples, you're fine.
You just have to make sure you have enough classes to support every case.
Right. So like this is a 4-class, this is a 4-class model.
Yep.
So if all of a sudden you want to change it and you want to identify a 5th class, like you want to identify that low density part of the matrix, now you're looking at, you have to add a 5th class. Now you have to retrain the model. Or if your samples change, like let's say you're dealing with concrete and all of a sudden they want to identify the rebar in the concrete. Well, now not only are you adding a class, now your material is changing as well.
Mm-hmm.
So now we need to start looking at maybe making a different model or just retraining that model so that it knows what that extra material is.
And we are starting to see some of the more generic algorithms like that segment anything tool.
Right.
But even that was a little limited because it's whatever you click on is differentiating that from the rest of the stuff.
Yeah. If it can see the difference in the grayscale, then it'll isolate it.
I mean, we're not removing the need for people to be specialists. We're not removing the need for somebody to be good at their base knowledge of this stuff.
Somebody has to know what they're doing.
Yeah, we're just helping out with this task, which can be very tedious. You had to do it by hand all the time on every sample. So it's a force multiplier.
Yes. Yeah. Yes. Exactly.
Well, that's really cool. And that, I think, was the last question that we had. Thanks for joining us, Billy.
Absolutely. Happy to be here.
Yeah, this was This is really cool. I think this is like game changing.
Yeah,
For a lot of this stuff.
It's a lot, but it's very, very cool.
Yeah. And remember too, though, with your Bruker tool, if you got like a new Poseidon, something like that, you also have some of our tools, so CTVox and CTN for doing your analysis. Those work really well too. This isn't always the best one. That's not. You got to find the right thing for what you're doing.
What workflow works best for your
That's
setup?
right. Yeah, a lot of things you can do in either. So this just happens to be what we're talking about today.
Yep.
All right. Thanks everybody out there for spending the time with us today. And until next time, keep your signal high and your background